Chapter 12.3, we're going to be going over measures of central tendency. So starting with a couple definitions. So the word average, an average is going to be a number that represents the middle of a group of data. And there's a couple different averages. We have the mean is an average, the median is an average, the mode is an average, and mid-range is also an example of an average. So we're going to go through each one of these four and see how they're calculated, and we're also going to see when they are used. Okay, so let's start with the mean. So the mean is also called the arithmetic mean. It's going to be symbolized with an X with a bar over the top, and we read it as X bar. So we use X bar when we're talking about the mean of a sample. We're going to use mu, which is a Greek letter, when we are working with a population. So unless otherwise stated, when we're doing problems here, we're going to assume that the data represents a sample. So we're going to be using X bar. So for the mean of a data set, it's going to be this little formula right here. It's going to be the sum of the data divided by the number of pieces of data. So this is the most common one of the averages. So usually when someone refers to an average, they're talking about the mean. So let's see this example. We want to determine the mean age of a group of firefighters if the ages are 30, 21, 51, 37, and 51. So it's going to be X bar equals the sum of all of the data entries X divided by how many there are. So this is going to be adding all of the data entries up together. So 30 plus 21 plus 51 plus 37 plus 51. There are 5 data entries here. So we're going to divide by 5. And we're going to end up getting 190 over 5. So we end up getting X bar, the mean is 38. So that is X bar equals 38, and this is an age, so I'm just going to label this 38 years. If you're typing this in the calculator, just make sure you put parentheses around that whole entire numerator, just to make sure it does order of operations correctly. So what the mean actually kind of represents, it's essentially like a balancing point for a set of data. So if we have our data right here on this horizontal axis, we have the squares represent the ages in the example that we just did. The mean of 38 is right here. So it's kind of like the middle of a seesaw, keeping everything in balance. Okay, the next one that we're going to be doing is going to be the median. To find the median of a set of data, we're going to rank the data in order from smallest to largest. And once we have the data in order, the median is going to be the middle value in the ranked set of data. So let's do that same example, determine the median age of the group of firefighters with these same ages. So we're going to go ahead and put these in order first. So that's going to be 21, 30, 37, 51, and 51. So if we're trying to determine the middle one, we're just going to cross off as we go until we hit the middle. So the middle value here is 37. So that means the median age here is 37 years old. So there is just one little trick for this, and that's going to come down to whether or not there's an even number or an odd number of data entries. The one that we just did, there was an odd number of data entries. So when this happens, the median is going to be just the entry that's directly in the middle. But when there is an even number of pieces of data, the median is actually going to be halfway between the two middle pieces. So for odd, we were left over with just one piece in the middle. For even, we're going to be left over with 2 pieces in the middle. And what that means is we're going to have to essentially find the mean of the 2 middle pieces. which means we're going to have to add them up and divide by 2. So let's go ahead and see how we do that with these examples. Determine the median. So the first one, it looks like we have to put this data set in order. So let's go ahead and do that. That's going to be 9, 11, cross them off as we go, 11, 12, 14, 16, 16, 17. So when we're trying to find the median here and we start crossing off from the ends, we get to the middle and there's 2 middle values this time. So the median is going to be the mean of the 2 middle pieces, which means we have to add them up, divide by 2. That's 26 over 2. So the median here is 13. So sometimes the median, if we have an odd number of data entries, isn't even going to be one of our actual data entries. So let's see another one. We have 7, 8, 8, 8, 9, 10. So these ones are already in order for us, so all we have to do is cross off. And once we get to the middle, we get 8 and 8. So this one's a little bit easier. We don't really have to add them up and divide by 2, because obviously the answer is just going to be 8 here. But if we did do that, 8 plus 8 divided by 2, that's going to give us 16 over 2, which once again obviously is just 8. So if the 2 middle numbers are the same, then the median is just that number. Okay, now the third average we're going to be looking at is the mode. So the mode is going to be the piece of data that occurs most frequently. So let's do that same exact example we've been doing with the age of the firefighters. So we have their ages. So the mode is going to be the number that appears the most. 51 occurs twice. So that occurs more than any other number. So that means the mode is 51. Okay, for a mode, a data set can have no mode, one mode, or multiple modes. The one we just did, it just had one mode. So if each piece of data occurs only once, then there's no mode. If 2 values in a data set occur more than once, or occur more than all the other data, we consider these values to both be modes, and we call the data set bimodal. So bimodal meaning 2 modes. So let's see this example right here. We want to determine the mode of the following set of data. We have 2 1s and we also have 2 3s. So that means 1 and 3 are both the mode. They both appear twice. And that means that this data set is bimodal. And for the last average we're going to talk about here is going to be the mid-range. So the mid-range is the value that's going to be halfway between the lowest and the highest value in the data set. So what that means is it's going to be the lowest value plus the highest value divided by 2. It's essentially just the mean between the lowest and the highest value. Let's do that same example now. Determine the mid-range of this group of firefighters' ages, and we have to identify the smallest and the largest value, and that's going to end up being 21 and 51. So it obviously doesn't matter which 51 you choose. So that's 21 plus 51 divided by 2, which gives us 72 divided by 2, and that gives us 36. So the mid-range for this data set is 36, only takes into account the smallest value and the largest value. So for that same example that we just did, we did it 4 different ways. The average of those ages, 30, 21, 51, 37, and 51. We got 4 different answers. We got 38 for the mean, 37 for the median, 51 for the mode. and 36 for the mid-range. So let's do another example where we'll just do them all at the same time. So this is the salaries of 8 selected social workers rounded to the nearest $1,000. We have 40, 25, 28, 35, 42, 60, 60, and 73. And let's start by calculating the mean. We know that the mean is going to be x bar. It's going to be the sum of all of the x's over n. So this summation symbol is sigma, and it represents summation, which means we're just adding all of the x's. I just forgot to mention that on the first page. So adding all of these x's up, we add them all up and divide by how many there are. There are 8 of them. And we end up getting 363 divided by 8, which gives us 45.375. And that is our mean x bar. Let's go ahead and take a look at the median. So first, what we have to do for the median is take all of these data entries from the question, and we have to put them in order. Here is the data from the question, just put in order. So let's go ahead and figure out the median, cross off 2 at a time from the ends as we go. So we get down to the inner 2. We had an even number of data entries, so we should expect this to happen. So that means the median is going to be the mean of those 2, which means we add them up and divide by 2. Hopefully it's pretty obvious that the answer is going to be 41. It's just the halfway point between 40 and 42. And we get 82 divided by 2. So we get 41. So the median is 41. And next for the mean. So we have the data set already right in front of us. The mean, or the mode rather, the mode is clearly 60 because it appears twice. So that one's always pretty simple. You just have to see which one occurs the most. And lastly, for the mid-range is going to be the smallest value plus the largest value divided by 2. The smallest value is 25. The largest value is 73. So let's go ahead and add those up and divide them by 2. So 25 plus 73 is 98. Divided by 2 is 49. That gives us a mid-range of 49. So it's always good to go back and just kind of take a look at these and compare them. The mid-range is 49, the mode is 60, the median is 41, and the mean is 45.375. Now we're going to briefly discuss when we should be using each one of these different averages. The mean is definitely the most commonly used average. I'm sure when you hear the term average, you think of taking the mean of a set of data. But the issue with this is it can be affected by any change in the set of data. So for example, if we have this data set, 1, 2, 3, 4, 5, 6, 87, and we took the mean of this data set, this value at the top here is going to pull the mean in the direction to the right. So the mean might not necessarily represent the middle very well, depending on the situation. So we can call that 87 an extreme value, or you can actually call it an outlier as well. So when you have that outlier, sometimes it's going to be best to use the median as the average instead of the mean. If that number was a 8 instead of an 87, the median of this data set would actually be the same as if it were an 87. Let's see this example here. So consider a set of exam scores from a math class. So here are all of the exam scores, 0, 16, 19, 65, all the way up to 92. We want to know which average would best represent these grades. if we went ahead and calculated the mean for this, if you add all of these test grades up and divide by how many there are, you'd get a mean of 64.06. And if you found the median, so these are already in order, so the median would be pretty easy to find. The median would end up being 71. So we want to compare these and see which one might better reflect the middle of the data set here, the center of the data set, or the average. It probably seems like the median is better here. There are only 3 data sets or 3 data entries below the mean. The mean is 64.06. So there's only 3 data entries below the mean, which doesn't really seem like it represents the middle very well, because there's all of these other ones that are above the mean. If we take a look where the median is, so the median's obviously right in the middle. It is right here, median of 71. So this one might seem a little bit better in this case, so the median of 71 would probably be a better average to use for this example. So let's go over some examples to see when the mode would be used for an average. We know that the mode is going to be the piece of data that occurs most frequently. So for some examples where this would come in handy would be for something like builders that are planning houses are interested in the most common family size, just to accommodate the average family. Also, retailers ordering shirts are interested in the most common shirt size. So those are just a couple examples where the mode would be used as an average. And lastly, the mid-range. The mid-range for a data set can be used when whatever is being studied is constantly changing. So for example, something like the average daily temperature, you can't really calculate the average daily temperature very easily. You'd have to constantly be reading the temperature to take the average of it. So it might be easiest to just add the lowest value and the highest value of the day and divide that sum by 2. This should say day. So that's an example of when the mid-range might be used, is when the data is constantly changing. For the last thing for this section, we're going to go over measures of position. So measures of position are going to be used to describe the position of a single piece of data relative to the entire set of data. And we typically use measures of position when we want to make comparisons, and usually when the data set is very large, this will come in handy. Two of the ones that we're going to be doing, these aren't the only ones, are going to be percentiles and quartiles. So first let's look at percentiles here. So there's 99 percentiles. There's not 100 percentiles, there's only 99. There's 99 percentiles dividing a set of data into 100 equal parts. For example, suppose you scored a 520 on the math portion of the SAT, and that score was reported to be in the 78th percentile of all high school students. What that means, it doesn't mean you got a 78%, you didn't get 78% correct. It means you scored higher than 78% of the other students. So in general, if you are on the nth percentile, it means you outperformed n% of the population. So it's a nice comparison to see what your score is in relation to the rest of the population. And let's do this example. Kara took an English achievement test to obtain college credit by exam for freshman English. Her score was at the 81st percentile, so let's explain what this means. This means that Kara scored better than 81% of the other students, which also means that 81%, or about 81%, of the scores are below Kara's score. Let's do one more thing here with quartiles. Quartiles are going to divide the data into 4 equal parts. There's going to be 3 different quartiles. The first quartile is going to be the value that's higher than about 25% of the population, which is the same as the 25th percentile. The second quartile is going to be the value that's higher than 50% of the population. And it's important to notice that the second quartile is the same as the median. Lastly, the third quartile is going to be the value that's higher than 75% of the population, which would be the 75th percentile. So we can see how the quartiles are split up. If the blue line represents the data set, then Q2 is the median, and there's half of the data to the left, half of the data to the right. Q1 is actually going to be the median of the first half of data. Q3 is going to be the median of the second half of data. And then we can see how it's divided into 4 equal parts. Here are the steps for determining the quartiles of a set of data. First, we're going to make sure the data is in order from smallest to largest. Next step, we're going to determine the median. The median is the second quartile. And then the first quartile is going to be the median of the lower half of data. The third quartile is going to be the median of the upper half of data. Let's go ahead and see this example. Electronics World is concerned about the high turnover of its sales staff. A survey was done to determine how long in months the sales staff had been in their current positions, and below are the responses of 27 sales staff, and we want to determine Q1, Q2, Q3, the first and second and third quartile. First, we need to organize the data in order from smallest to greatest. So here is the data in order. Since the data set was kind of large, I don't think I'd be able to fit it all in order, so I just did it in rows. Finding the median. So for this one, if you were finding the median, you just kind of have to cross off starting like this at opposite ends until you got to the middle. You would see that the middle is going to be 17. That means the median is 17. And since we know that the median is the same as the second quartile, that means the second quartile is also 17. Now what we would do is we would try to find the median of this first half of data. So we're trying to find the median of that first half of data. And it looks like that's going to end up being a 9. Looks like it's going to be this value right here. That's going to be Q1, the first quartile. Lastly, for Q3, that's going to be the median of the second half of data. That's going to be the median between these values right here. And that's going to end up being 24. So 24 is going to be the third quartile. So what this means is about 25% of the data is below 9, about 50% of the data is below 17, and about 75% of the data is below 24. Okay, so that is it for this chapter.